AB-620, Copilot Studio Authentication, User Identity, Connections, and Secure Tools. The last two lessons gave us the two big integration jobs. Tools perform work in systems. Knowledge sources ground what the agent says. But there is a question underneath both of those jobs that the exam loves. Whose authority is crossing the boundary? That is the authentication problem. Authentication is not just a login screen. In an agent design, authentication answers three practical questions. Who is calling the external system? What credential is being used? And what data boundary is crossed when the call happens? Keep this rule in your head for AB-620. Tools do the work. Knowledge grounds the answer, and authentication decides whose permission is used. If you can identify the identity behind the call, a lot of connector, REST API, MCP, and connected agent scenarios become easier. Start with connector tools because they show the identity decision most clearly. Copilot Studio connector tools support two credential modes: user-provided credentials and maker-provided credentials. The names sound simple, but the consequences are huge. User-provided credentials mean the agent acts on behalf of each individual user. The first time the connector is invoked, the user signs in to the connected service with their own account. The connector call then runs under that user's permissions. This is the right choice when each user has their own account in the target system. Data access should match that user's permissions, or the agent is delegating the user's own work. Think about an Outlook connector that sends an email. If an employee asks the agent to send a message, the message should come from that employee's mailbox. The employee's identity matters. The agent should not send all mail from one shared service account. Maker-provided credentials are different. In that mode, the agent uses the maker's connection for all users. In practice, that usually means a shared service identity or configured connection. This can be the right choice when individual users do not have accounts in the target system, when all users should reach the same scope of data, or when asking each user to sign in would break the experience. For example, an IT service desk agent might submit incidents into a service management system using a dedicated service account. Employees may not have direct accounts in that system. The agent needs to create a ticket on their behalf, but the back-end write operation runs through the shared service connection. The exam trap is forgetting the channel requirement. Maker-provided credentials require an authenticated channel. If the agent is configured for an anonymous or unauthenticated channel, the maker-provided option may not even appear. So, the decision is not only credentials, it is identity plus deployment channel. There is also a collaboration detail. If multiple makers work on the same agent, they need access to the underlying connection to build and test the integration. Sharing the agent is not always enough. The connection itself may need to be shared with can-use plus share permission. Now, move to REST API tools. A REST API tool starts from an open API specification, but the spec does not solve authentication. Copilot Studio supports three authentication options for REST API tools: None, API Key, and OAuth 2.0. None means the API is openly accessible. Use that only when the endpoint truly does not require credentials. It should not be your default mental model for enterprise APIs. API key means the API expects a secret value in a header or query parameter. The maker configures the user-facing label, the exact parameter name, and where the parameter goes. If the API expects a header named XAPI key, the parameter name must match. Header is usually preferable to query when the API supports it. OAuth 2.0 means the API uses an identity provider. For REST API tools, the maker provides client and endpoint details such as client ID, client secret, authorization URL, token URL, refresh URL, scopes, and organization or client restrictions. This is the stronger pattern when the API needs an identity provider and scoped authorization. REST API tools have two more exam cues. First, the source material marks them as preview and not suited for production use. Second, you should expose only the endpoints and HTTP methods the agent actually needs. A giant open API spec with every endpoint turned on creates unnecessary surface area and makes orchestration less accurate. Minimal tool surface is both a security pattern and an orchestration quality pattern. The HTTP request node is even more direct. It is a node inside a topic that sends a specific HTTP request: dynamic URL, method, headers, body, response schema, and output variable. Because the node is visible on the topic canvas, secret handling matters. Never hard-code API keys, bearer tokens, or other credentials directly in HTTP headers. Any maker with access to the topic canvas can see those values. Store the secret in an environment variable and reference that variable from the header value. That keeps the credential out of the canvas and makes it manageable across environments. A secure HTTP request design also includes a response schema and error path. Use sample JSON to define the fields the topic needs, then store the response in a variable. Capture only the fields the topic actually uses. If the API can fail, configure continue on error, capture the status code and error body, and branch on the status code. A 200 response shows the result. Anything else routes to a safe fallback message instead of exposing raw backend details or ending the conversation without explanation. MCP adds another security layer. A model context protocol server can publish many tools from one centrally managed server. Copilot Studio supports 3 authentication types for MCP connections: None, API key, and OAuth 2.0. None is only for fully trusted situations where other controls are enough. API key means users provide their own key when the tool is first used. The maker configures where the key goes, such as a header or query parameter, and the parameter name, but the maker does not embed the key value in the configuration. OAuth 2.0 delegates authentication to an identity provider and is the stronger choice for production scenarios when the server supports it. OAuth for MCP has 3 subtypes. Dynamic discovery is best when the server supports dynamic client registration with a discovery endpoint. Dynamic is used when the server supports dynamic client registration, but the maker must provide authorization and token URLs. Manual is used when the identity provider does not support dynamic client registration, so the maker must provide client ID, client secret, endpoint URLs, refresh URL, and scopes. The choice is not a preference. It depends on what the server and identity provider support. MCP also has a tool surface governance decision: allow all. If allow all is on, the agent can use every tool the server publishes, including new tools added later. That is convenient, but it trusts the server owner to publish only tools that are safe and relevant for this agent. If allow all is off, the maker explicitly enables the tools this agent should use. New tools are disabled by default and require review. This matters because MCP tool descriptions are read-only in Copilot Studio. The orchestrator reads the descriptions the server owner provides. If a tool description is vague or overlaps with another tool, the maker cannot fix it locally inside Copilot Studio. They need to work with the server owner. For AB-620, that means MCP governance is not only authentication, it is also tool selection and description quality. Now connect this to knowledge and connected agents. Knowledge sources and connected agents can also cross data boundaries. A real-time connector knowledge source calls a live system. Azure AI Search may cite internal documents. A connected agent can receive conversation context. A Foundry agent connection can send user messages and conversation history to a Foundry-hosted agent. So the security question becomes, is the data allowed to leave this agent's boundary? Has the connected capability completed the organization's responsible AI review? Does it log or retain conversation content? Are there users or use cases where routing to that agent would be inappropriate? For Copilot Studio connected agents, the source agent must be published in the same environment, have connections enabled, and be owned or shared with the orchestrator maker. When connecting, the maker can configure whether conversation history is passed to the connected agent. Passing history can improve context, but it also changes the data boundary. Disable it when forwarding conversation context is not appropriate. Now put the full decision tree together. If the scenario says the agent must act with each user's own permissions, choose user-provided credentials or user-scoped OAuth. If it says users do not have backend accounts and a shared service identity should perform the work, choose maker-provided credentials, but check for an authenticated channel. If it says REST API or MCP with a secret, choose API key only when that is what the system supports, and configure the parameter exactly. If it says strong identity provider and scoped authorization, choose OAuth. If it says a value is a secret, keep it out of the topic canvas and use environment variables or a managed connection. And if this scenario says another agent, MCP server, Foundry agent, or live knowledge source will process user data, ask about the data boundary. What data is sent? Who controls the destination? Is it logged? Is it governed? Does the user have permission? Does the maker need to restrict tools or turn off conversation history passing? For AB-620, listen for these exam cues: user permissions, signed in user, maker-provided credentials, authenticated channel, service account, shared connection, API key, OAuth, client secret, scopes, environment variable, bearer token, continue on error, status code, MCP authentication, allow all, read-only tool descriptions, conversation history, responsible AI review, and data processing terms. The final rule is simple. Tools do the work. Knowledge grounds the answer. Authentication decides whose authority is used. Governance decides whether that boundary is safe. When a Copilot Studio design question mentions a connector, API, MCP server, or connected agent, do not stop at what the agent calls. Ask who is calling, what credential is used, and what data boundary is crossed.